Welcome pre-calculus students to another day in our unit on sequences. In our previous lesson, I introduced you to what a sequence was and to this idea of a sequence being defined explicitly. Okay, so that was one type of sequence formula that you will see. In today's lesson, we will cover the second type of defining a sequence, which is this idea of using a recursive formula. All right, so let's get to it. So first, a recap. So a sequence is said to be defined explicitly if you can simply find any term by plugging in the respective term number. So if we do a quick example here, if I were to just make one up here, so a sub n is equal to 2n minus 1, that sequence would be defined explicitly because, for example, if I wanted to find the 10th term in our sequence, I would just do a sub 10, 2 times 10 minus 1. So I would just plug in 10 into the formula and I would get 19. Okay, so that was a sequence that is defined explicitly. Now let's look at a sequence, or what a sequence looks like that is defined recursively. So defining a sequence recursively. So a recursive formula is a formula that relates each term to previous terms. Okay, so a recursive formula is a formula relating each term to previous terms. So in other words, we're describing our pattern of numbers. We're describing our pattern of numbers by what are we doing to the previous term to get to the next term. Okay, what are we doing to the previous term to get to the next term? So if we look at an example really quickly here. Okay, now you'll see here, so this sequence is defined recursively. You'll see here that there's actually two parts to this sequence. There's the first term given to us, right, b sub 1, and then there's the formula here, okay? So that's one change that you will see when it comes to this idea of defining a sequence recursively. And it's this idea that when you're defining a sequence recursively, or if you're looking at a recursive formula, you will always be given the initial term, So in this case, as you can see, we are given b sub 1, or the first term of our sequence, right? So the first term of our sequence is given to us. Now, it's not always going to be the first term. It could be the second term, it could be the third term, but they will give us a term. They will give us a term for a sequence that is defined recursively. They will give you a term to start with. And the reason why is this second part of the formula. You'll see b sub n, so that's nothing new. We've seen that before. But here we have something new. We have b sub n minus 1 plus 2. So what is that? What is that? B sub n minus 1 plus 2. Well, the plus 2 is pretty self-explanatory. Well, what is this? What is this b sub n minus 1? Well, let's think about what that subscript represents. Remember, that subscript represents the term number, okay? The term number. Well, if the subscript is n minus 1, so that would mean the term number minus 1. So in other words, that would mean the previous term. The previous term. If you're subtracting 1 from your term number, that means you're looking at the previous term. Okay? You're looking at the previous term. So for example, let's do a quick example. So since we're already given the first term, let's say we were trying to find the second term. All right, let's say we were trying to find the second term of this sequence. So we would do b sub 2 is equal to, pay close attention to how I'm plugging this in, would be equal to b sub 2 minus 1, because remember there is a minus 1 there, so I'm replacing the n with a 2, so I'm doing 2 minus 1 because that's what the subscript is, plus 2. Well, let's see. Come on. Sorry about that. 2 minus 1 is just 1, so that means we end up with b sub 1 plus 2. Well, what is b sub 1? Well, b sub 1 is 3, right? It was given to us. b sub 1 is equal to 3. So I'm going to substitute this 3 in for that b sub 1 here. So we end up with 3 plus 2, which gives us 5. Okay, 3 plus 2, which gives us 5. So there you go. We added 2 to the previous term to get 5. Let's do one more example. Let's say we wanted to find the third term. So once again, the second term is 5. The second term is 5. So I'm going to write that over here. So b sub 2 is equal to 5. Let's say if we wanted to find the third term, so b sub 3. So b sub 3 is equal to b sub 3 minus 1 plus 2. Well, let's see. 3 minus 1 is just 2. So that gives me b sub 2 plus 2. Well, b sub 2, we calculated earlier, is equal to 5. B sub 2 is equal to 5. So I'm going to substitute that. In for b sub 2. So I end up with 5 plus 2 is equal to 7. So that means the third term is equal to 7. And there you go. And then you would just continue on from there if you wanted to find more terms, obviously. But as you can see here, what we're doing, because ultimately the question is, well, what is this sequence telling us to do? Well, remember, if this n minus 1 is just your previous term, right? So think about it. You're taking your term and you're subtracting 1. So think of it as you're going one place backwards. So if we're talking about the second term, you're going to the first term. If you're talking about the third term, you're going to the second term, so on and so forth. So you're going one term previously. So you're taking your previous term and then you're adding 2 to it, right? Which hopefully you can see this happening, right? Because the first term was 3, the second term was 5, and the third term was 7. So it looks like we're just adding 2 every single time. Okay, we're just adding 2 every single time. So if we wanted to interpret this, like what is this telling us to do? It's telling us take previous number or previous term and add 2. Okay, that's how one would interpret that. Take the previous number or term in your sequence and then just add 2 to it. Okay. So as you can see, this is where a recursive formula and an explicit formula really shows their differences. Because, for example, if we wanted to do, let's say, b sub 10, right? Let's say if we wanted to find the 10th term, well, that would mean we would have to do b sub 10 minus 1 plus 2. So that's b sub 9. Uh-oh. We don't know what b sub 9 is. We know what b sub 1 is. We know what b sub 2 and b sub 3 is. So we know the first, second, and third term. We have no idea what the 9th term is. So one disadvantage of recursive formulas is you always have to know the previous term. If you don't know what the previous term is, you're limited to what term you can find. So for example, if we wanted to find the 10th term with a recursive formula, we would have to do the 9th, which would mean we would have to do the 8th, the 7th, the 6th, the 5th, because we would have to know all the terms before that to figure it out. As opposed to an explicit formula, right, we saw a couple slides ago, you would just plug in 10 and you would calculate, you would have your answer. So as you can see, there is a disadvantage to using this recursive sequence. All right. So let's quickly try this out. Using this recursive formula. Or wait, did we already try it? We already found some of the terms. So we already found the second term and third term. All right. So we found the second term. So we said it was 5. We already found the third term, which we said it was 7. So then if we wanted to do the fourth term, so let's see. So that would be b sub 4 minus 1 plus 2. So b sub 3 plus 2, b sub 3 is 7, plus 2 is equal to 9, right? B sub 3 is 7, so that goes in for that term, so 7 plus 2 gives you 9. And then you can keep on going from there, right? If you wanted to find b sub 5, that would be 9 plus 2, because once again, you're taking the previous term and just adding 2 to it. And then b sub 6 would be equal to 11 plus 2. And then this also asks us to find the 100th term. Yeah, that's going to be a little bit tricky because we would need to know the 99th term to do that. Okay, and we're not going to go through finding all those terms before that to figure out what the 100th term is. Okay, so when it comes to recursive sequences or recursive formulas, you're going to be limited. You're going to be limited as to what you can do. It's a little bit easier to describe what's happening, right? As some of you have seen in some of our bell ringers, it's easier to just say, it's easier to see something like this and say, oh, it's just adding by 2 every single time, right? So it's easy to write it as a recursive formula, but it's a little bit tricky to go from here to, oh, the explicit formula is 2n, whoa, I got to think about this for a second, 2n plus 3. Oh, no, I'm sorry, 2n plus 1. Got that wrong. Okay, so it's one advantage of defining a sequence recursively is that it's easier to figure out the formula, right? It's easier to figure out the formula. The first term is 3, and then, forgot to write 3 here. First term is 3, and then we're just adding 2 every single time, so you would literally put previous term plus 2, and there you'd have it. Okay, so now let's look at actually finding a recursive formula or defining a recursive formula. So let's say you're given this list of numbers. And this is actually a famous list of numbers called the Fibonacci sequence, all right? So you'll see 1, 1, 2, 3, 5, 8, 13, 21, 34. All right. You'll be asking yourself, okay, what in the world's going on? So let's see. So here the difference is 0, then 1, then 1, then 2, then 3, then 5, then 8. Then 13. All right. Well, it doesn't look like there's any pattern here. If we took it a step further and found the second difference, 1, 0, 1, 1, 2, 3, 5. Yeah, that's not helping us. So what in the world is going on here? So this is actually a famous, like I said, this is a famous sequence. Some of you might have seen it before. And it's famous because of the way it's constructed. So here you'll see, right, here you'll see that if we just took the difference between the numbers, we can't really figure anything out. But if we did something else, look at this. Well, actually, let me quickly calculate the next number, and you might actually figure out what's going on. So the next number here is actually 55. And then the next number after that would be 89. Have you figured it out yet? No? So what's going on here actually, and maybe some of you have figured it out already, what's going on here actually is to find the next term, right? To find 55, what I actually did was I took 21 and 34 and added those up. And to find 89, I took 34 and 55 and added them up. So to find the next term, you always take the previous 2 terms and add them up. Okay, so to find the next term, you take the previous 2 terms and add them up. Okay, so the next term would be, let's see, 55 plus 89, what is this, 144, I believe? So 144 would be the next term. And then so on and so forth, okay? So, well, what would the sequence look like? Well, once again, since this is a recursive, or since we're writing a recursive formula for this, remember there's 2 parts. You always have to say what the first term is. So in this case, we say the first term is 1. Okay, say the first term is 1. And then we have to define a more concrete formula where we take the previous term. Well, we just said that to find the next term, you take the 2 previous terms. So not only do I take the term before, but I also take the term before that. Okay? So, did I make a mistake here? Should that one be 1? I think I am missing something. Yeah, I think I'm missing 0 here. Should be 0. There we go. That makes more sense. So wait. Am I still messing that up? I'm trying to think what I did wrong here. So the second term is 1. Actually, I'm going to write it this way. Wait, if I write it as that doesn't work. So I do a sub. Yeah, a sub 1 is equal to, yeah, that's good. All right. And there you have it. But let's look at, or let's think of one more example before you try out some problems on your own. Let's think of one more example. Let's do, I don't know, off the top of my head, like -3, 0, 3, 6, 9. All right. Let's say that's your sequence of numbers. All right. Let's say that's your sequence of numbers, and you want to define it recursively. Okay. You want to define it recursively. So you take your first term. It's -3. Take your first term. That's -3. And I hope the pattern is pretty obvious, right? It looks like we're just adding 3 every single time. -3 to 0, to 3, to 6, to 9. So we're just adding 3 every single time to go from one term to the next. So once again, if we're adding 3 every single time, that means we're taking the previous term, and adding 3, right? Taking the previous term and adding 3. Okay, remember, if you ever want to take the previous term, okay, if you ever want to take the previous term, you have to subtract 1 from that original subscript. So if your subscript is n, you just subtract 1 from it, and then so on and so forth. So remember, all this is saying is previous term plus 3. That's all that is saying. Previous term plus 3. And that's what you're doing, right? To find 0, we do -3 plus 3. To find 3, 0 plus 3. To find the next one, we would do 9 plus 3. Give us 12, so on and so forth. Okay, so that is what we're doing. And that is how you would find a recursive formula for a given sequence. All right, so the rest of the problems are on your own problems. Okay, the rest of the problems are on your own problems. So just writing the first 5 terms, so you literally just follow it like I did in the previous one. Same thing goes with here, C and D. Just make sure you write it out, write out all the work so that it's clear as in terms of exactly what's happening. And then finally at the end here, you have a sequence that you want to try to write a recursive formula for, like we did in that last problem. Okay, all these problems will be on Desmos. Okay, all these problems will be on Desmos, so you can complete them all there. As usual, please write out all your work so that it's clear the steps that you are following. Otherwise, that is the end of the lesson. I hope it went smoothly. If you have any questions, always feel free to reach out to me. But otherwise, I hope you guys stay safe, and I hope you enjoy the rest of your days. See you later.